With many of our functions, we're going to be curious over the course of its domain, how does a graph change? What's its average rate of change? Or what's its slope that we'll be introducing to you here pretty soon. So the idea is that our graphs rise and fall. How quickly do they rise or fall? Well, one of the models we can use is this model right here that describes the average rate of change. And again, something we'll unpack as we progress, and we're getting real close to being able to do that. So for right now, I want to show you how we could use that with this particular function. F of x equals 2x squared minus x plus 3. Well, what's its average rate of change over its domain? Well, this model helps us get us there. So let's look at how we can solve this. First thing we want to know is what's the function evaluated at x plus h? All right, a couple things to notice first of all. Yuck, it looks ugly. But that's right. We were learning that we can solve problems by just starting with a small one and working our way through. So we can do that. Also, I noticed that I put parentheses around all my values to make sure I don't lose a distribution of a negative or making sure I'm squaring everything to the correct power and whatnot. All right, let's just start working this slowly. X plus h squared, that is x squared plus 2xh plus h squared, if we remember how to factor, or how to multiply those two factors, minus x minus h plus a 3. All right, let's clean that up a little bit if we can. And that becomes 2x squared plus 4xh plus 2h squared minus x minus h plus 3. Combine like terms, if there's any like terms to combine. There are not. Now remember, what we found was just the f of x minus h. We want to take this function and subtract from it, or subtract to it, the other function, f of x. So let's go ahead and write this out. My f of x plus h. Here, we'll kind of do this. Minus f of x. F of x plus h was all of this junk. Then subtract f of x from it. I'm going to subtract the entire function, so I'm going to make sure I have put parentheses around it. So that becomes and that's all divided by h. Able to see all those things? My f of x plus h is right here, minus my f of x divided by h. Now it's just as simple of just cleaning it on up and looking for things to disappear, I hope. So let's, again, write it all the way out. Have to write out because now I want to distribute the 2x squared, or the negative. Makes that a positive x, makes that a negative 3. All divided by h. From there, do you see anything that cancels out? I do. So let's get the canceling out marker and let's have fun with that. So I have a negative 2x squared, cancels out with a 2x squared. I have an x, positive x, cancels out with this x. I have a 3 and a negative 3 that cancels each other out. And from there, I don't see anything else that, I don't know, let's clean it up a little bit and see. So I'm left with a 4xh plus a 2h squared minus an h all over an h. Okay, there's no more like terms, but I was saying h an awful lot there. So it looks like what I can do, I'm trying to find space to do that, is let's go ahead and factor out an h. So that's 4x plus a 2h minus 1 all over h. And let's just work that backwards. 4xh, h times 2h gives me 2h squared, h times 1 gives me a negative h all over h. From there, we can go ahead and factor out an h on the numerator and the denominator. And then what's left of this entire average rate chunk function is 4x plus 2h minus 1. So the average rate of change of this initial function over the course domain is modeled by 4x plus 2h minus 1. And this h, we'll describe that pretty soon, right, coming on up. So for right now, just treat it as a variable that's going to kind of represent the distance that we're looking at over incremental periods of time.